Hello and welcome to the Bearded Mathman's YouTube channel. Hey, in this episode, what we're going to be talking about, inequalities in one variable. We're going to just do the basic introduction. I want you to come away knowing how to read, write, and graph. And backwards too. Given a graph, could you write an inequality? And could you write that statement out in English? In other words, can you read it? So let's get to it, shall we? I'm going to ask you a series of questions right here. They're going to be in yellow blocks. And that is actually what the math is going to be. I'm going to teach you how to read the math, and we're going to write the answers underneath, and that's what the graphs are going to be. So let's get into it. Here we go. What number is less than 5? Well, you might say, duh, of course. 4, 3, 2, and 1, right? But is there a smallest answer? What about negative infinity? Well, it's not really a number, but the idea is right. You know, there's smaller numbers keep going forever and ever, so there isn't the smallest number. What about a biggest answer? Less than 5, 4.9 forever? Well, that gets a little tricky too, but the idea here is right. You can get as close to 5 as you want, but you can't go up to 5. So what number is less than 5? Well, anything less than 5, all the way up to, but not including the number 5. And that's kind of a key idea, right? So all numbers smaller than 5, up to, but not including 5. That would be the answer. So what we're going to see how to do here is we're going to learn how to read the math when this is written mathematically, and we're going to learn how to graph this answer. That's what we're going to learn how to do, all right? So now, next question. We're going to have 3 more questions. This next question is, what number is greater than or equal to negative 2? Now, this is a little bit of a different question. What number is greater than or equal to negative 2? Now, you might have an idea, but let me ask you, is there a smallest answer? Well, it says greater than or equal to negative 2. So there is a smallest answer in this one. Negative 2 is the smallest answer. Anything smaller than that isn't greater than negative 2, of course. What about biggest answers? Well, once again, numbers keep going forever. They get larger and larger, so there is not a largest answer, but there is a smallest. So our answer to this question is all numbers more than 2, including negative 2. All right, so what if we put those two questions together? What number is less than 5, but greater than or equal to 2? What number is less than 5, but greater than or equal to negative 2? Boy, that's really kind of a tricky thing. Now, you might realize that when we put these two things together, we have kind of an interesting situation. Our smallest answer, there is one. It's negative 2. Our biggest answer, there isn't one. So we can go as close to 5 as we want, but it doesn't go on forever. So we have anything more than negative 2, including negative 2, of course, and all the way up to, but not including 5. Now, our last question might seem kind of, well, obvious. What number is not 3? Well, of course, anything but 3. What's going to end up happening is we're going to have to learn how to graph this. And if you can graph this, then you really understand what's going on, all right? Now, here's a number line. Number line is just a straight horizontal line, goes left and right, no big deal. We're going to say the number 5 is right there. Right? To the left of 5, that's where all the smaller numbers than 5 exist. And to the right of 5, well, that's where all the numbers that are larger than 5 exist. So what we're going to do is I'm going to teach you how to draw a picture of this. All numbers smaller than 5, up to, but not including 5. What we use to signify that is an open circle. An open circle means that the 5 is not included. All right, now, if we wanted to include the 5, it's a different question. This is a picture of all of the numbers less than 5, including 5. So if you have a solid dot, that means your number is included. If you have an open circle, that means your number is not included. So the picture of this, the graph that matches this statement right here, all numbers smaller than 5, up to, but not including 5, looks just like that. Good to go? All right, so one last thing. When we're talking about a graph, wherever our line is, that's where, or wherever it's shaded, that's where all of our answers are. And where it's not shaded or where our line is not, there are no answers there. There's no numbers to the right of 5 that are less than 5. So there's nothing shaded over here. But everything to the left of 5 on a number line is smaller, right? So what do you think the 3, not 3, is going to look like? Well, since this means not included, we're going to put a circle around the 3, and then we have a line going in both directions, because everything to the right of 3 is not 3, and everything to the left of 3, not 3. So just not 3 is, or just 3 is not 3, so we put a circle around it, right? So an open circle, that's how we're going to call it. An open circle means that number is not included. When we talk about -2 and it's included, we're going to use a solid dot, right? So x, or a number, any number that is greater than or equal to -2 is going to look just like that. What do you think that our last one's going to look like, though? Take a minute and think about it. If you have a piece of paper right there in front of you, why don't you go ahead and try? All right, here we go. Here's what it looks like. It looks like a combination of our first two questions. It's more than -2, but it could be like -2, so we have a solid dot, but it's also got to be less than 5, so it's an open circle. So all of the numbers that would meet these conditions, that it's more than -2 but less than 5, would fit somewhere in between them on a number line. Now, we're talking about graphing. What a graph is a picture of all solutions. So when we're graphing these things, what we're doing is we're drawing a picture of every possible answer. Now, when you were learning how to solve equations, like x plus 3 equals 5, x would be 2 as your answer, right? Well, there's no need to graph that because it's just one answer, but these have lots of solutions. Now, what a solution is, in case you're not sure, a solution is a value that makes a statement true. Now, here are all of the symbols we're going to be using. I'm going to encourage you to make sure you use the correct language. When you see this, if you say is less than, then you're actually making this statement right here. What number is less than 5? And that makes writing math and reading math so much easier because you don't have to remember what to do. You're just reading it and answering it. Now we're going to say x is our variable. That means it's something we don't know, right? So let's go ahead and try to write this first one. So instead of x, what we're going to say is what number, right? So what number is x is less than is this symbol. So what number is less than 5 would be this. What number is less than 5? X is less than 5. What number is less than 5? That's how we would write it. Okay, now, here's x is greater than or equal to -2, and x is not 3. X is not equal to 3. Now, this last one's a little tricky. Let me ask you a question. If x is greater than -2, could you also say that -2 is less than x? Those are the same, right? Yeah, absolutely. Now, we also know for this one right here, all numbers starting with 2 and going up. So what number is less than 5 is the tricky part. Greater than -2 we have. Well, we know what x is less than 5 looks like. And so this, what number is less than 5, but is also greater than or equal to -2? It's going to look like this. -2 less than or equal to x is less than 5. Yeah. All right. So now let's do a quick checkup. Let's see where you're at. Do you know how to write an inequality and draw a graph if you were given a statement? Like this one right here. What number is less than or equal to 8? Well, first of all, what would the statement be in math? If you said x is less than or equal to 8, just like this, you're good to go. Now, on the graph, we're going to have a solid dot on the number 8, and it's going to be shaded to the left because that's where all the smaller numbers than x are, right? Now, you could write this in a different way. These have the same meaning. So what you cannot do is you cannot say, oh, I shade it to the left because the arrow points to the left. That's not why you shade to the left. You shade to the left because this means less than. So x is less than 8. All the numbers that are less than 8 are to the left of 8 on a number line. All right, now, let's see. Could you, if you were given something like this graph right here, could you write an inequality that matches it? Go ahead and try it. Did you get x is greater than or equal to -4? Yeah. Could you write a sentence of that? It's just like what we just said. What number is greater than or equal to -4? That's it. If you can do all that, you're doing great. You're doing fantastic. You're ready for what comes next, right? Now, last one. Can you make a graph of this? And could you write that in a written statement? Go ahead and try it. Now, the written statement is, what number is greater than 4, but less than or equal to 5? Now, the graph here, this is a strict inequality, less than 4. Sorry, x is greater than 4. 4 is less than x. So on the 4, we have an open circle, and it says x is less than or equal to 5. So 5 gets a solid dot. Let me ask you a question. What are the smallest and largest numbers that are solutions to this? Do you know? Well, there's not a smallest, but it is bound. You can't go past 4. There is a biggest, 5. Did you get that right? Okay, now, a couple questions. We're almost done. Why is it that some inequalities have a smallest answer and others don't? Do you know? Could an inequality have a largest and a smallest answer? Why do we use a circle or a solid dot in a graph? And what is a graph? Hey, try those questions. If you want to know the answers, well, I'll put a link in the description below that you can follow, and you can see how you did. Now, if you would like some practice problems, I will put a link to download this worksheet in the description below. You can check it out. Hey, if you found this video to be useful, give it a thumbs up, share it, and if you want to be notified of when new stuff is released, hey, go ahead and subscribe. What's to lose? It's free, right? Anyway, I thank you for your time. Hope it's been helpful. Leave me a comment down below if you have any other questions. And if you're ready to go after this one, in the next video, we're going to be talking about how to do some slightly more complicated inequalities. Thank you again.